Good afternoon, everyone, and welcome to today's webinar on metal casting simulation. My name is Corinne Bossy. I work in the marketing team at Altair UK, and I will be your host for today's webinar. So we've got two presenters on the line for you today, Rob Shropshire and Tim Dukes from Origin. Origin is a partner company of Altair, and they specialize in simulation for the manufacturing industry. And in today's webinar, they will talk about the Altair Inspire Cast solution. Just a couple of housekeeping items before we start. Your microphones are muted, but you can use the questions box in the GoToWebinar panel to ask questions at any time during the presentation. Rob and Tim will be available at the end of the session to answer any of your questions. The session is recorded as well, so if for whatever reason you cannot stay until the end, you will receive a link to watch the recording afterwards. Okay, I will just turn you over to Rob now to get started.
Thanks very much, Corinne, and thanks everyone for joining us on today's session. Special thanks to the Cast Metals Federation as well for allowing us to host it in conjunction with them. Just by way of introduction, I'm Rob Shropshire and I lead the sales and marketing side of Origin. I won't be doing a lot of the talking today apart from a short introduction, but I will be your contact should you wish to chat to us moving forward post event. I'm really pleased to be joined by Tim Dukes, who is a co-director of Origin and is our subject matter expert. He's spent the last 10 years or so in and around the manufacturing space and leads all things product related, as well as providing training and support to our customers. In terms of agenda, as I said, keep the introductions short, but I do think it's important to set some context in terms of how we help our customers and what we're seeing in the industry, particularly in terms of simulation. I'll then pass on to Tim, who will discuss and go for a few slides on what Inspire Cast is, what types of challenges it helps casting companies solve, before he'll then jump into a live demonstration and show you how it all works. As Corinne said, please ask some questions. We'd rather it be interactive. We'll make sure we get to them towards the end. When Tim goes into the demonstration, I would also suggest you just make sure that you're maximizing your screen to make sure you can see everything within the software. So Origin have around 200 customers, all of whom are in the manufacturing space. I think what's unique about Origin is our sort of focus on design and manufacturing engineers, and really advocating for simulation much earlier in the design process. So we know that simulation tools are used by some organizations, but it's often when perhaps something goes wrong, or it's often when mold design has already actually taken place. So we think doing it much earlier has some merit. Of course, some businesses will do simulation, but they'll go ahead and outsource it. But of course, there is a time problem there in terms of longer delivery timeframes and perhaps an increase to your costs worth considering. We've partnered with Altair because we feel the solution provides the functionality you need, but it provides it at a fraction of the cost compared to a lot of the other solutions out there. We also know that tools have to be easy to use so that people can pick it up quite quickly. And Inspire Cast only takes a day to learn, and you don't have to be a simulation expert. And hopefully you'll see how easy it is to use a bit later on. So as I said, we believe simulation should be done much earlier in the design workflow. The benefits are clear, but not a lot of companies seem to be using it at those earlier stages. The most obvious benefit of simulation is to allow customers to spot defects early before a mold or parts made, and Tim will certainly go through some of those a bit later on in the session. As well as eliminating defects, by giving designers the ability to run simulations, they can often explore more designs faster. And in many cases, this can allow businesses to improve the yield that they're getting from each production run, ultimately improving their profitability. Another interesting idea is just being better than your competition. Companies that are able to provide a sort of visual demonstration of how a part's going to be manufactured, I would argue, are much more likely to go ahead and win the business. And I think by empowering staff with simulation tools, we believe companies can deliver a better service to their customers. They can be more competitive, perhaps, with some of the larger organizations that already have this technology in-house and in place, while still improving their own productivity. So I think it's worth just commenting on the casting industry in general. I think what we're seeing is that a lot of businesses have tended to rely on the experience of their staff to deliver quality products, and rightly so. That seems like a sensible thing to do. The problem is that the workforce is getting older, and those skills are becoming harder to replace. So when those people leave the business, so too do the skills. And I'm sure every attempt is made to try and transfer that knowledge, but it's simply not possible to transfer 30 or 40 years worth of wisdom to someone that might just be starting out their career in the casting industry. So if we look at the people that are entering the business, perhaps the graduates, most of them have been taught simulation at university, and actually they're very used to using software to validate their decision making and their designs. I would also argue they're more comfortable doing that way. It's the same way that many people will just YouTube something or watch a video to learn how to do something. So not only is simulation an approach to ensure quality and improve productivity, but we think it can actually help to future-proof a business's operations. And not to state the obvious, we know that costs are going up quite drastically, and also overseas companies are offering services and often undercutting UK businesses and doing it at a cheaper price. So businesses really should be using every single tool they can to improve that productivity and reduce their costs in order to stay competitive. So just a few more slides from me. Altair did do some research and commissioned engineering.com to do an independent research report just to look at how manufacturing organizations are using simulation. So I just wanted to touch upon a few of those now. If we look at how simulation technologies are being used at the moment, we can see that only 17% use dedicated simulation tools, which isn't very high in my opinion, and 14% just don't bother using it at all. Perhaps they're just relying on staff know-how, or perhaps they feel that the jobs they do don't require it. On the right-hand side, perhaps more interesting is the stage in that workflow, in that design and manufacturing workflow where it's actually being used. Nearly half of companies are just waiting till something breaks or something fails. And we would, of course, argue that one production run going wrong is likely to be much more expensive than just getting a simulation tool in place or using simulation much earlier on in the process. 40%, only 40% are doing it in that early design phase. We think there's lots of opportunity there. So I think what we want for our customers is that they don't go and produce a part or mold before they've done this simulation to avoid wasted time and money. Now, before I move on, I think Corinne is going to put up a poll now on screen, because we'd love to know a little bit more about whether you do use simulation or not, and if you don't use it, what perhaps that reason is, and we'll share those results with you. So I'll just wait 20 or so seconds, and hopefully everyone on the call wouldn't mind just quickly filling that in. I'll just wait 10 or so more seconds. Corinne, let me know if you want me to hold on a bit longer, but if not, I'll carry on.
I think most people have voted. I've just shared the results on the screen, so you can see basically the responses. Quite a mix of people online today.
Good. Well, thank you. I think there are a couple more questions towards the end, but we won't interrupt you with too many of those. But we always find it interesting to see how it's being used. So just a final slide from me then. this is the actual benefits. So if you haven't got it and you need a business case, let us know. We'll send you some of this research. But on the left-hand side, these are the results that businesses were expecting. These are the things that got the business to buy the simulation software in the first place. So you can see that a lot of the time it is about reducing the cost of producing the parts or the cost of designing the molds, speeding up production and increasing quality through reducing or eliminating those defects. On the right hand side, you're seeing the actual results that they've realized post implementation. So obviously you can see here that over half are reporting a reduction in cost. Other interesting benefits of faster time to market, which I imagine keeps your customers happy, perhaps keeps the competition out. And obviously having higher yields and reduced downtime means more things being produced, less wastage, which clearly impacts their bottom line. So I hope from the short introduction it provides some context in terms of why we think simulation earlier on in the process is very important, and hopefully it's at least worth a discussion internally with your peers. I think for those that aren't already using simulation, it's a great opportunity to get it in actually at a very affordable price. And there will be no doubt people on the call today that already have simulation software in place for casting. But what we often find is that the price of these solutions actually makes it prohibitive to give to too many people, when in fact other designers in your business may well see value or need that simulation. So there are also examples of some of our customers that yes might use other simulation tools, but have actually also implemented Altair to provide to other members of staff as well, because it is such an affordable product. So I think that's enough from me. Tim, I will pass over to you now.
So yeah, hi guys, thanks for the introduction, Rob. I'll be taking you through the Inspire Cast solution. Before I get straight into like the demo and showing you the actual software, I thought we'd just sort of set the scene, just explain some of the casting processes that Inspire Cast can simulate. And then sort of like, what is Inspire Cast and why we sort of advocate for using casting simulation. So first of all, what is casting? Most of you will be aware of what casting is. So casting is obviously where metal is heated to become molten metal. It's poured into a mold which contains a cavity. Once the metal is solidified or frozen, the mold is the part is either ejected from the mold or it's broken from the mold, depending on whether you're using a permanent or a non-permanent die. And also generally, depending on the part that you're actually trying to cast, you may use one process over another. Some casting processes have advantages and over others. So I think casting is probably one of the oldest manufacturing methods known to man. I think just a bit of googling. I think the oldest casting that's ever been found is a copper frog. I think it's about 5,000 years old. So it's a fairly old process. Maybe not all the processes, but casting itself is. So we're just going to go through a couple of the different processes, starting with gravity casting. So in gravity casting, you've generally got gravity sand or gravity die. So the sand casting, we've got a non-permanent mold. Die casting, obviously we've got a permanent mold. In both of these methods, the liquid metal or molten metal is poured from a cup, a ladle, vessel, and poured into the mold with no other help or no other forces other than the force of gravity, allowing that mold to be sort of filled. Obviously the flow rate can be controlled by how you pour that, but it's just purely gravity that is allowing that mold to be filled. There's obviously benefits to both types of casting, whether you're using sand or die. If you're doing high volume casting, maybe a permanent die may be preferred. So benefits to both. Next casting method that we will look at within the software is investment loss wax, also known as. So we can see the image on the right. This is sort of the process and how this is done. So the process basically starts with a wax pattern being produced. This is generally produced through injection molding or 3D printing. The actual wax pattern is the cast part. It's an exact replica of that part. Once this pattern's been produced, it's assembled onto your runner system, your sprue system. If it's a multi-part cavity, it might be assembled onto what we call a tree. So we can see in this image, we've got sort of a tree of parts. Once this is done, it's dipped into a ceramic slurry to coat the wax. And this is done numerous times until you've got your required thickness. Once this is solidified, you will basically heat this up in a furnace or an autoclave potentially. This will melt the wax, so then the wax is obviously lost, and that's another reason why it's called lost wax. Once we've done this, we're left with a ceramic mold. This is generally like sort of heat treated before the molten metal is poured in to allow it to sort of withstand those high temperatures. So the molten metal is then again poured into the mold, solidifies, and the mold is broken, and you get your cast parts. Some advantages to investment casting are you get fairly like a high degree of accuracy, a high degree of detail to the parts can be achieved. Next process we'll just briefly touch on is high pressure. So in high pressure die casting, this is where molten metal or liquid metal is injected into a permanent die at high pressures. So again, we can see the process here. Generally, this is done via a shot sleeve. These dies can be used thousands and thousands of times. So again, useful for high volume parts. High pressure die casting is also known to be used for parts with fairly thin wall sections, thin cross sections, because you can achieve this high accuracy with high pressure die casting. The actual dies themselves very strong. Obviously, they've got to be able to withstand that molten material hitting the mold at high pressures, and clamping forces are required to sort of hold that mold in place. Different types of high pressure, you might have cold chamber or hot chamber. Finally, we'll just touch on low pressure die casting. So sort of almost like the opposite of high pressure. So this is casted at a low pressure. So in low pressure, the aluminium is sort of drawn up into the mold through a riser, and by doing this, you potentially avoiding defects such as oxidization, air inclusions, and by doing this process, you generally get a fairly good surface finish, and again, you're getting this accurate dimensioning. So different parts are potentially cast using different processes. So these are the sort of processes that we can sort of simulate within Inspire Cast. Just a couple of parts, so you can see the parts you might see cast in certain different ways. I won't spend too long on that slide, but you'll be familiar with some of these sort of casting methods and the parts that can be produced by each one. So now we'll just touch on sort of what is Inspire Cast. Inspire Cast is a casting simulation tool. It allows you to simulate the filling of your molds and also the solidification of the metal. So it allows you to do virtual testing rather than trial and error prototyping. It allows you to do these in the virtual stage, which hopefully increases your manufacturing speed. We believe it's got fairly fast onboarding. So what we mean by this is it doesn't take long to learn. A lot of users self-teach. Generally within a day of training, you can be up and running and be more than comfortable using the software. It's got a nice the licensing model. I won't go too much into detail on that, to be fair, but in essence it's a floating license, but it's a cloud-based. The license is actually in the cloud. Software is run locally, but if anyone has got any questions on licensing, feel free to drop us a message. Nice easy 5-step workflow, and so from importing your initial CAD model to actually getting results is a nice simple 5-step workflow. What this means is that any engineer, regardless of any skill level, can use this software, hopefully. Just briefly touch on how it works. So you import a 3D CAD model. The software basically meshes that model. It basically turns the CAD model into a triangulated mesh. These the mesh is then made up, the part is then made up of elements. So you might be able to see this image on the right hand side. It's got like a little mesh. And these are individual elements, and basically a simplified version is that the software is basically running calculations on each of these elements that allows it to simulate the filling and the solidification processes. The meshing, you don't have to be a simulation expert. People sometimes think, meshing is quite complicated. You don't need to be. The software does auto mesh. You've got full control over like sizing and things, but you don't need to be a simulation expert to be able to mesh these parts in Inspire. So briefly touched on that 5-step workflow a couple of slides ago, and this is the 5-step workflow. We'll see this in the live demo shortly, but in the image to the top right, this is the workflow, and you always work sort of left to right. But your 5-step workflow is basically step 1, you designate your cast part, and what this means is you choose the part that's going to be cast. You specify a material, a grade, a pouring temperature. You can then define a runner, and you can also specify your gravity direction. Second step is to add gates or designate surfaces as gates. Third step, assign or designate casting components. So you can create risers, sleeves, cores, chillers, all your different types of casting components you can create in your third step or assign. Fourth step, set up your casting process. So whether you're doing investment casting, whether you're doing tilt pouring, gravity, high pressure, low pressure, this is the fourth step. And then the fifth step is specify your mesh sizing and actually get some results. So we're on sort of like why use Inspire Cast. Rob's briefly touched on this. So obviously one of the main reasons to use simulation in general is to sort of hopefully identify problems or defects before manufacture. By doing this, hopefully you're reducing that trial and error stage, and which increases your manufacturing speed. So some examples of defects everyone will probably be aware of. You've got micro porosity on the left-hand side, middle, we've got some macro porosity, and then we've got just some other defects that you may come into when casting. So obviously that's probably the main reason, the reason most people think of. Other reasons to use simulation is actually to sort of guide you on your method creation. So where is the best place to add gates? Where are the best places to add risers? What size risers could I potentially use to draw out these defects? And by optimizing this method, can you increase your yield? Which, as Rob mentioned, if you're increasing your yield, should improve costs, improve profitability. And then the last stage is, again, like if you can prove through simulation that you're able to cast a part without defects, does that give you an advantage if you are bidding for work? So if you can prove that your method works and it's going to be defect free, does that give you an advantage when bidding for work? We believe it probably does. So outcomes of using Inspire Cast, a couple more slides and then we'll jump into a demo. Study all the stages of the casting process. So this is the filling, solidification, and we also can study some thermomechanical analysis, things like residual stress, displacement within Inspire Cast. And finally, to identify the defects, and hopefully by identifying them, you can improve your method. So these are the questions that you might ask yourself before when getting a part, and can I fill this part? Where are the best gate positions? What happens if I change the material? How does this part solidify? Does the part have any defects? And if it does have defects, where are they? And can I change the method to hopefully reduce or remove them? So things like porosity, where is it? Can I draw this out? Can I improve my yield? So these are the sort of questions that you might ask yourself. What we're going to go into now is a live demonstration. So I'm going to share hopefully share my software screen. 2 seconds. And okay. Hopefully you are seeing.
We can see that, Tim. Yeah.
Brilliant. Cheers, Rob. So going to give you a 30-minute demonstration of the actual software itself. This demonstration is going to be based around sort of method engineering, sort of a simple method engineering workflow. It's going to be on a gravity part, but the same workflow can be used for any casting process. First of all, I'll just spend 2 minutes just getting you familiar with the user interface in Inspire Cast. So we like to think it's a fairly clean, fairly nice looking user interface, easy to navigate. and that obviously lends itself to being easy to use. You've got your tabs along the top, so you can see here these are your tabs. We're in the casting tab at the moment. This is the right hand side one, and here you can see this 5-step workflow that we've spoken about. So obviously that we'll be looking at shortly. Just to go through the tabs, we've got your geometry tab. So this allows you to obviously create and modify geometry within Inspire Cast. So if you need to make any geometry changes, sometimes you may get sent cast parts that have features that are going to be machined afterwards. Generally, you want to remove those because if they've got large holes in areas, potentially that may affect your casting results. So those are the sort of things you may want to get rid of. So we've got tools that allow you to do that. But there are other modeling and geometry modification tools within here. So these are your 3D tools. Then you've got your sketch tab. So 2D sketching tools. So this allows you to create, again, geometry within Inspire Cast itself. It's not a 3D CAD solution. So just be aware of it's a simulation tool, but it does have CAD functionality within it. So you can do some basic creation. Your view tab, that is literally just how you like to view the Inspire Cast software. So you'll notice I've got my model browser and property editor ticked on. So these are these things on the left hand side here. You can just see if I untick them both, they disappear. So I like to view my model browser. I like to see when I import a part, I like to see all the components and the things that are actually within that part assembly. So that's your view tab. You've got your edit tab, which is pretty much just your window shortcuts. These are things like copy and paste, undo, redo. Those are your sort of window shortcuts. And then you've got your standard file. So here, very standard throughout most softwares, you've got your opening and your saving. From your file tab, you can do things like screen capture. So we can take snapshots, we can take videos, screen recording. So we can do that. From here, you can also access the help files and the tutorials. So that's all from file. And then you've got your licensing as well. So once you've activated your license, and this is done just through an email and a password from your account creation, the license is activated then. And once you open the software, you grab that license. What's nice about the software is you can take that license into an offline mode. Some scenarios where that might be useful is maybe you're going on to a supplier site and you might not have internet connection. You want to be able to show them a simulation, that sort of thing. So any time where you need to take that license away, that could be useful. Another thing is if you're running a simulation overnight, you're leaving at 5 and you just want to run a simulation before you leave, and occasionally we know Wi-Fi sometimes goes down, internet drops out. So that's useful to be able to put that into an offline mode. So so we'll just finally, you can got your manufacturing units down here. So you can choose these manufacturing units and you can also customize them. So for example, if you want to work with millimeters, but you actually want your temperature to be displayed in Kelvin, you've got all that functionality and customization here. So they're your manufacturing units. Just to the left of here, you've got all your views. So you can rotate between your views, ISO, perspective, and you can also do section cuts throughout your model. So if you need to visualize maybe a mold temperature and you want to visualize that in different cuts, you can obviously create your section cuts throughout your model. So we're going to go into a live demo, and it's going to be sort of a basic method engineering workflow, and then I will show some different sort of examples of preloaded stuff with around different types of casting, such as tilt pour and investment casting, high pressure, and I'll show you some new features. So first of all, I'm going to just open a Parasolid file. So this is just a Parasolid file. We can import numerous different file types. So regardless of where you get your file types from, and what format, we can most likely open them. So you can see here we can open up CATIA, IGES, Inventor, Parasolid, SolidWorks, Step, you name it, we can probably open it. So so you're not limited to file types. So I'm going to open up a Parasolid, and this will import my 3D model into Inspire Cast. So we're going to go through that 5-step workflow. First of all, like as I mentioned, you know, if you do import a part and you think, okay, and areas are going to be machined after the casting, you might want to use some of your geometry tools to simplify the model. So I've got this tool here. In this instance, I'm just going to get rid of these 2 front holes, and I can just click on those, and we can see I've just defeatured the model. So you can use these tools for a number of reasons. Back into the casting tab, and I'll start my 5-step workflow. So the first step is to assign the cast part. So hopefully here you can see you've got 3 options. We can assign a material. So you can see all the different types of material that we can assign here. Once you've chosen the material you're using, you can then specify the grade. So you've got your different grades of material, and then your pouring temperature. So for example, if I'm using that AC42100, I might want to change that and say I'm actually pouring it at 730. So we can modify all these here. But if you want to actually open the material database, you click this tool here, and this will open up the actual material database. We should see that pop up in a second. So here we've got, again, control over your materials. Generally, I find in the UK, most people view materials with obviously the different standards, EN or ISO. So depending on how you like to view your materials, you can see the different standards. So we've got ISO and EN, and also ASTM and JIS. So all your different types of standards there, depending on how you like to view things. I'll just keep mine at EM. But these are all your material properties. So these are obviously the properties that allow you to get your results. So you've got all these different types of properties here. You can edit any of these materials. You can import materials. A nice new feature in the 2022 release is that we do have direct import capability from JMAT Pro. So if anyone uses JMAT Pro, you can actually import materials that you've created in there into Inspire Cast. So that's the materials. I'm just going to leave the material that I've got set there and right click to accept that. If we do have a runner system, we can designate that. We'll see that shortly. But then obviously gravity, quite important, gravity direction, so we can specify that. At the moment, this is actually in the correct location. It's in the -C direction. But we can specify any surface, so we can designate any surface as gravity. We can also rotate the model, and we can also flip the actual direction if it's upside down. So I'm happy with that. I'm going to accept that. So that's my initial first step done. Because I'm only going to do solidification analysis for my first stage, I'm not going to add any gates yet. So, but the second stage is basically you're able to add gates. So you can add gates in any location of your choice. We will see that very, very shortly. Third step is to add or assign components. So we can see here all the different types of components that we can add or assign. So if you have imported your part with the method on it already, you can designate. You've got 2 options on each of these. You've got add or designate. So this allows you to designate a component or a part already from your CAD system. So all these components can be created or added. Then you've got your setup. So we've got basic setup, which just allows you to specify a velocity or a filling time. Obviously, I'm not doing any of these yet because I'm not filling, but this is your basic setup. But then you've got gravity. From here, we've got a lot more control, such as spoon height. We can keep a constant liquid level and or flow rate. We can also specify tilt pouring or investment casting. Then just quickly looking at the other processes, we've got high pressure. So here we've got a number of different options, and once you've got different components set up, such as a shot sleeve, we can modify all these different variables. In the 2022 release, some nice new functionality has come out for high pressure die casting. This is a PQ2 diagram, so your machine parameters can now be computed. And also you're able to actually compute the required clamping forces to keep that die shut. So so there's some nice new functionality in the 2022 release. And then finally we've got low pressure. So this is low pressure, again controlling that that pressure as it fills. I'm just going to go take mine back to basic setup and just leave it as that for the time being. But then the final stage, the 5th step in the workflow, is the analysis. So this is where you're basically defining your element size. So hopefully we can see the options that we've got here. At the moment, we're using average thickness. So the part has been analysed and the average thickness of the part is 9.5 millimeters. And the element size I'm currently using would be 4.7. So it's basically half that. And that's because I've got this slider bar here. And you can just slide it whether you want to do a faster analysis or a more accurate analysis. And hopefully as I'm sliding this to like faster, the fastest we're seeing it literally just using one element for the average thickness. More accurate, you can see the element size is obviously getting a lot smaller. But you can control this yourself. I can say actually I want a 3mm element size. And the next step is to basically specify what you're doing, whether you're doing a filling or a solidification or both. And you can also compute deformation. By using this option, we can compute things like residual stress and deformation. You've also got cycling, so we can use cycling if we are. So these are your basic mesh settings. We do have more advanced options. So you've got things like component mesh factors, and also you've got an auto refinement. So if you do have got a part with thin walls and you want to make sure that in those areas, so we're looking here for any areas under 2mm or under, we want to make sure there's at least 3 element layers. You can do that as well. So we do have more advanced mesh settings. Just going to turn that off. So I'm going to just do a simple solidification analysis and I'm going to hit the run tool. One thing I didn't do was actually set up my mold. Just to show, I'll just leave it as default for now, but we can actually set up my mold component, obviously important when solidifying. So here, obviously I'm using this type of steel and a temperature, but we can set up the mold to be any temperature that I want. So I probably would have chosen a potentially a sand, or you can choose any component that you need to. With these components as well, you can also add coatings, and so that's your mold options there, and obviously your mold temperature. While this is running, we've got 2 stages. It's mesh the part straight away, so we've actually already gone from the meshing stage into the solidification stage. And what's quite nice about Inspire Cast is that you can actually view the results midway through. So if you're filling, as soon as you've got to 5%, you can actually view those results. So obviously I'm not going to be able to view the whole solidification process. You know, I've only got 5 seconds at the moment. But what's quite nice about this is midway through, I can straight away look at my mesh. So I can actually look at that mesh and say, okay, well, is that mesh fine enough? Am I getting small sections that are maybe being missed because my mesh isn't fine enough? So you can straight away view that. And if you did have any issues with your mesh, then you could potentially go back and just refine your mesh sizes a little bit. So my results are actually complete now. I can just load all those results in. Obviously at the moment, we're just purely looking at solidification. So if I just press play here, this will basically go through the solidification stage. We are just looking at temperature at the moment, so temperature evolution as the part solidifies. And I'll just turn off the mesh as well, because sometimes I like to view it without the actual mesh. So this is just purely temperature evolution, showing you that cooling phase of the material. But other things that we can look for in the solidification stage are things like solid fraction. We can look for, you know, mold temperature, displacement, porosity. So things that we might be interested in is the last liquid stage. So solid fraction allows you to see the areas that are last liquid. So if I hit that play button again, we can see those last liquid stages. The animation can be controlled. You can speed it up, slow it down, but you can also use the slider bar just to actually control it yourself. Sometimes I like to use this slider bar just to sort of manually close it. You can also just cycle through the steps individually, but straight away we can see obviously the material's split in here. Obviously we haven't got any method yet, but the last liquid area is splitting in this area here, and it's also in this area here. So those are the areas you'd probably expect to see some porosity. We won't go into every single result just because of time, but we'll be focusing really on solid fraction, porosity, and hopefully looking at some of the results that are useful. So we can straight away see that we're going to get, based on just purely solidification, we haven't obviously chosen where we're going to fill this. We're looking at these areas that maybe are the highest, might have the highest percentage of getting porosity in these 2 areas. So we've done a solidification. This is when we then might move on to gate locations. So where are the best gate locations for this part? So we can go back into our second step now, and we can start to actually add some gates. So I'm going to add a gate here, and when you're adding a gate, you get to choose a size. So we can choose a circular or a rectangular. If I choose rectangular, obviously I've got full control over the size of those gates. Also, you'll note that you can do sequential gating. So we can now do sequential gating in Inspire Cast. So we can have if you're doing multiple gates, you can have a start time and an end time. And you can also compute flow tracing. So these are two new options within Inspire Cast, and I'll show you an example of flow tracing at the end. So I'm going to add on 2 gates. Like, let's say my method's going to run down and fill these 2 gates, and that's where the material is going to fill from. So I'm accepting that. So this might just be like, again, as your method engineer, and you're looking for the best places to fill. I'm not going to be able to go through too many locations in this demo, again, just because of time, but you then would do your fill analysis, and we could then run a filling and a solidification analysis, and we could hit that run tool. So you can see the first stage is the meshing stage. As soon as that stage is completed, it'll jump straight into the solidification stage. What's quite nice is I haven't changed the mesh size, so it will jump through this stage, the meshing stage, fairly quickly, because it will actually be able to use the previous mesh. Obviously, if you are changing the mesh size, it won't do that. Rather than sort of wait for the results, we'll open up sort of one with results already preloaded, just because it may take 2 or 3 minutes to get sort of results for this. So I'm going to just load up a run that I did earlier, which I think is this one. So this one. We've got our 2 gate locations. In this instance, we use circular gates, but same thing. So here in our analysis, we're actually looking at the filling of this part. Again, we're just looking at temperature, so we can start to view how this part actually fills. So we can see how that part fills and the temperature evolution as it fills. So we can, look for certain areas. So other things that we can look for when it's filling, again, we can look for solid fraction. And if your part's struggling to fill, if it is freezing before it's actually full, we can look for areas that are potentially freezing before the part's actually fully finished. So we are getting a few areas down here that are starting to freeze before the part's full. We can look for velocities. So, mold degradation, if you're getting high velocities hitting your mold, that might lead to mold degradation. So that's something you might wish to look at, and you want to be able to control those velocities if possible. High pressure die casting, you might be interested in last air. That might guide you in the areas to put your overflows. So that's stuff you can look for. But these are all the different types of things that we can obviously look for in the filling analysis. Once you've looked at your filling analysis, that's when you go into your solidification stage, and we can then start to view different things again, looking at where that porosity is. We can see based on this filling, we're getting porosity in those locations. There is a rule of thumb here. It's the percentage, this volume area, the percentage of that will be porous is offset mine to 90%. So definitely going to be getting porosity here. Again, let's look at the solid fraction and see if that's any different to what we saw before. So we'd expect it to be the same because we haven't really got any method. So you can start to see how this part solidifies, and the last liquid areas, again, these areas here, which is leading to that porosity. So once you've done that, you might have investigated a few different gating locations. So you might have investigated a few and come up with the best, and said, okay, this is the best areas to gate this part. This is the best areas for the material to fill this part. And then you might go away and create a method based on those. So you then might open up, or I'm going to open up a part with an actual method on. So this has got a bit of a runner system attached to it. So we can see in this instance, I've actually got a runner system attached to it. You may create a few more components in your CAD system, like risers, sleeves, filters. You may also create all those in your CAD system. But again, we'll be going through the same workflow. So step 1, specify my cast part and your materials and your temperatures and your grades. accept that. Step 2, I have now got a runner system, so I can say that's my runner. Obviously gravity again, I'm happy with that, that's the same direction. And I still need to add a gate, so I need to know where this material is flowing in. So if I add that there, we can move this gate around. You know, you might not pour it, you might pour it off center. I can change the diameter, so we can do all that sort of thing. And then if you want to, you can add components within Inspire Cast. So I'm going to go into my components tab, and let's say, for example, I want to actually add a riser. So I might want to actually add a riser on this area here to hopefully potentially draw it out. So this riser might not be look exactly the same as risers you may potentially use, but it is just again a virtual example of a riser. But again, if you create a riser and it's just a cylinder, you can import that into Inspire Cast, no problem. If you want to add a sleeve, you can add a sleeve to a riser. We can choose isothermal, exothermal. You've got your temperatures and thicknesses, so we can add those. Other components we can obviously add are cores. Let's say I want to actually add a filter. I want to add a filter here to control the flow. And so we've got control over the filter and obviously all the sizes and things as well. So those are just a few of the different components that we can actually create within Inspire Cast. So once you've come up with your method, again, this is when you want to find, and last I'll just add a mold as well. That's probably useful to add. So if we want to add a mold, let's add Furan sand, choose a temperature. I'm going to bring the mold height down to obviously where it's being poured. So that's the top of the mold. So once you're happy with this is when you're happy with your method. You might be, okay, well, this is my final method. This is where you probably want to be doing a smaller element size. This is where you want to be controlling the element size and saying, okay, this is my final run, or one of my final runs. I want to get the most accurate results. So you want to take that element size down. So again, you're just doing this a smaller element size, specifying whether you're doing filling and solidification, and then you're hitting the run tool. Again, I'm not going to let you guys watch and wait for that to sort of finish. So let's just open a part with these results, or just this has actually just got 2 risers, no sleeve, no filter, but hopefully you'll be able to see the difference. These 2 risers make that actually fairly large. Maybe they don't need to be that large, but this will give you an idea of how this part fills. So again, we're seeing those risers filling last, which generally should mean that they're last liquid location. So let's have a look at the solidification results. Let's see if doing that has actually managed to draw out that porosity. So we can look at our porosity now, and straight away we're seeing that in the risers. So it's drawing out that porosity. If we do look at solid fraction, if I can click it, and I'm just going to just use that slider bar to slide it through, we can then start to see the effect this riser has. So we can start to see it is drawing out. We are potentially getting a little bit of porosity, so that might be a bit of a worry. So you can always decrease your porosity slider bar and see if there isn't any going to be there. But the majority of it is going to be in the risers based on this method. So so that's just a quick sort of workflow on method engineering with Inspire Cast. That same thing can be done whether you're doing low pressure, high pressure, investment casting. The same workflow can be used. So what I'm going to just go through now, guys, is a few examples of just other casting methods in here. So if I open up a different file, the first one I'll just show you is tilt pouring. So we can simulate tilt pouring in Inspire Cast, and these ones might look a little bit more interesting to fill. So here we've got our crucibles, and we've got our tilt pouring rotation. So when doing a tilt pouring, you can see I've specified tilt pouring. You can still control the other things, but you've basically got your time and your angle that you can control. So I'll just close that, and let's view the results. It will load in a second. Okay, so our results have loaded. Again, we're just looking at filling here, guys. I'm not going to be able to go through all the results just because of time. But if I hit the play button, we can see the effect how this part is filling. So the outline, the body outline, is the final position. So I'll turn that off in a second because you can control all that fully. So your body outline is the final position, and we can hopefully see how that fills. We can, as I said, we can show or hide the outline, and if I just play that again without the outline, you can see again how this part fills. So so that's tilt pouring. Again, not going to go through all the different results with these guys, again, just because I've got time. I'll just open up an investment casting. With this one, I'll show you obviously the mold, and I'll show you a new functionality within Inspire Cast, which is being able to predict residual stress in a part after the solidification process. So this is just a very quick example of investment casting. Again, results are already preloaded, so I can just load those. I'll just quickly show you the filling animation first, and then we'll show you the solidification stage. Obviously, the filling analysis is just again gravity. So that's the part filling. If I go into the solidification results, which are now labelled as thermomechanical, and make sure I go to the end, the final, so it's actually solidified, and I'm just going to turn on this again. So here, I'll show you first mold temperature. So what you'll notice here is obviously when we are doing this investment casting process, we specify investment casting, we can specify a shell thickness, a mold temperature, and the material. Generally this is ceramic, but that's the material that we can specify. Just loading those results again. Here, I'm just going to just go to stresses, so von Mises. So this is the, again, residual stress. If I put some call outs on the part, so you can put call outs on the part at any stage. I prefer to view mine not as M bar. I'm going to do it in millimeters, I like MPa. So we can see the residual stress in the part. So this could guide you potentially in whether the part needs to be heat treated afterwards to try and remove that residual stress, or whether, you know, that's going to be a critical area. It's got a high residual stress. Adding that onto what the actual part is doing, you know, will it that cause the part to fail? So obviously that's quite important to be able to calculate that. So that's something that we can now do. Finally, I'll just open up an example. I've got two more examples. Probably got about another 1 or 2 minutes where I'll show you. We've got high pressure. I'll just show you a high pressure one. And again, with the high pressure, you've got your setup, full control over setup. So here we're using a shot sleeve. We can specify the percentage filled. Again, this is in Kelvin. I've just changed my results, but all this can be controlled here. Let's just change that back to millimeters. All this can be controlled, so you can control this chart by literally manually moving these points, or obviously typing in values here and modifying the length and the velocity at that point. So just again hitting the solve button. And in this one, we'll obviously see the part being filled, obviously the effect of that shot sleeve. Within high pressure, obviously you're getting that velocity change where you're filling and then it's injecting the part into it at a very high pressure. You'll see from the animation the time it takes. So what you want to be taking notice of is the time. It'll take about 0.6 seconds to fill to the sort of the runner, and then it's going to take 0.5 seconds to finish that that filling. So you want to be taking note of the time taken as well. So you can see you're getting that first fairly a slower velocity and then an increase in velocity, which you're not really seeing. Obviously, some probably my mesh there is a bit dodgy, but you're not really seeing the phase change. But what you want to note is the actual time. So we can see at this point we've got 0.58 seconds. It's just hitting that runner system, and then it's taking 0.4 or 5 seconds to actually fill the part. So obviously that's your high pressure. Finally, just one last one. I think I've got an example of, it says sequential gating, but actually it's not an example of that. It is just flow tracing. So if I view this part, what I just wanted to show you here is tracer IDs. So this just allows you to actually visualize the effect of each gate. So in this one, a new feature, we can obviously visualize the effect, the material that's coming from each gate and the effect it's having. So you can see whether you potentially need gates in certain locations, but you can also do sequential gating where this part fills, one starts to fill at X amount of seconds or whatever. So so that's the demo, guys. Hopefully you saw a few things in there that hopefully made sense. But that's just a quick overview, sort of 20-30 minutes overview of Inspire Cast. Obviously, if you do have any questions, just feel free to put them in. But I will share my other screen to sort of take me back to demo.
Yeah, thanks, Tim. Maybe just put our contact details up just at the end.
Yeah,
I think in terms of next steps for people on the call, I don't think we need to show another slide because we're short on time and want to answer some questions. But we'd love to talk to you further. We're very happy to provide perhaps a more tailored demonstration with one of your parts. Once you've had another session and understand the product a bit more, we can also support you through a trial, so you can sort of test it out for yourself and work out how easy it is to use. Or sometimes it's just a case of getting some information in terms of how to justify the investment, and we've obviously got experience with that, having done it with other organisations, so we're happy to help with that as well. Corinne has put another poll, a final poll, which is just asking you whether you sort of want anything else specifically from us at this point, whether it's more information, costs, trials, demonstrations. So feel free to enter that. But just the last couple of minutes, if you haven't put your questions in already, please ask them now, just while we do a bit of Q&A. Corinne, I'm not sure whether any questions have come in already that the audience would like us to answer.
Yes, I'm just checking now. We've got a couple questions. So the first one regarding the demo, how does the selected mesh size affect the component's property? So I think
so I don't know if, are you guys still seeing my screen, my Inspire Cast screen? I'm not sure if I'm still showing it.
No, I can't see it.
Are you on the poll?
I think I can see it now. Yeah.
Okay. So if you're seeing my screen, yeah, you can specify the component factor. So in this instance, I've only got a mold and my gates, so there's not many components. But you can actually specify your component factor within the meshing. So generally, if you've got a fairly basic mold, just a block mold, you might want to factor that up by 15 times. So it's a much larger mesh size than the part. So I don't know if that answers your question. If I've misunderstood, please let us know. But
there is a follow-up actually from the same person. They're saying, as far as I know, the mesh selection is very important. How does the program decide on the mesh size?
Yeah, so it's again, you can control your mesh factors with each component. So the mold, the runners, that can be controlled. You can obviously also control it via this auto refinement. Mesh size is important, but Altair, we use Altair's meshing behind the scenes, which is very powerful meshing, and that looks at areas of, for example, high curvature, and it will apply more mesh points to that point. If it's a very plain, no featured face, that face would have less mesh points. But you do obviously also control it, so you do set a minimum size via here, minimum size mesh, or you also do your auto refinement and make sure you've definitely got 3-4 layers at certain wall thicknesses. So so that's how it sort of controls it. So it is doing it in the background, but you do have a fair amount of control over that. I'll just share my other screen, guys, so I can just leave our details as well while
Any more questions, Corinne, while Tim
There is another one, which is, where did it go? Could this be appropriate for lost wax casting for jewellery?
I wouldn't see why not. I think it probably could. Yes, definitely. No reason why it couldn't. Definitely, lost wax and jewelry casting. There's no real size. Obviously, that's going to be smaller sizes, but it just means you can have a smaller mesh size. But it's just factoring things down.
Okay. Someone is asking, can you recommend what computing specs you need? Might be maybe some information we can share after the call offline in terms of specifications.
Yeah, so yeah, I could definitely share that after, but generally, again, like the more in simulation in general, the more cores you have, the quicker your simulations will run. If you've got a 2-core machine versus a 16-core machine, the 16-core machine is going to simulate faster. So cores definitely help, and that's again your processor, so your CPU. So again, the better the CPU, the better the quicker you're going to get results, really. So it's just about speed of getting results. But we can definitely send specs if they want.
Perfect, thank you. There is another question regarding high pressure die casting. Can you predict forces on the die to predict ejection forces, which die half the part is going to stick to?
Good question. So we can definitely predict now clamping forces, which allow you to predict the forces needed to actually hold that die in place. So whether you can use them to obviously predict the ejection forces potentially, but I'll have to get back to you on that one because that's a good question.
Very good. And well, I think one last question is, why should we use Inspire Cast over other casting simulation projects?
Do you want to jump in, Rob?
Yeah, I mean, I think one of the key things which we think is important is that it's a very easy tool to use. So we think in terms of user interface, it's one of the easiest tools to use in terms of casting, which means that people can pick it up quite quickly, and there's a low training curve just a day. We probably shouldn't sell on price, but I will anyway. When you look at casting simulation technology, you can be looking at upwards of £30,000 per year for the software, even up to 100, depending on which software vendor you go for. Altair's products are priced at about £9,000 per year for a floating license, which compared to the market is much more affordable. So in terms of quickly exploring and doing your mold design and validating your designs, we don't think there is anything else out there that is as easy to use and as well priced as Altair. But if anyone's got any specific pieces of software they're looking at or considering, each software vendor will have its pros and cons. All we can do really is investigate what you need to use the product for and show you what we can do. But hopefully in a roundabout way, that sort of answers why we think Altair is good. Tim, have you got anything to add on that or not?
No, I think that's probably that's what I would say myself. Yeah.
Perfect. So I don't see any more questions. If you've got any other questions, feel free to just reach out, to Rob or Tim. The email address is on the screen, and we'll send you a link to the recording of today's session as well, sometime tomorrow. So again, just reply back to the email if you've got additional questions. And I would like to thank Rob and Tim for presenting today, and all of you for attending this session as well. Thank you, everybody, and I think we're going to close the session now.
Thanks very much, everyone.
Thanks, guys.
Thank you. Bye-bye.